Welcome back to this M1 tutorial on the January 2009 paper. Here's question 4, and what we've got is a bench consisting of consists of a plank which is resting in a horizontal position on two thin vertical legs. Plank is modeled as a uniform rod. That means the mass will act directly in the center of the rod, and it's telling us the mass is 20 kilograms, so the force down will be 20 G, and the total length is 2.4 meters. And that means that this distance between the midpoint and Q will be 0.8 meters. Between the midpoint and R will also be 0.8 meters. There's two pupils, Arthur and Beatrice, sits on the plank. Arthur is max 60 kilograms and sits in the middle of the plank. So effectively what we have now here is 80 G, because 20 plus 60 is 80. And Beatrice sits at NP 40 G. It's telling us the plank remains horizontal in equilibrium, and by modeling the pupils as particles, find the magnitude of the normal reaction between the plank and the legs at Q, and the same at R. So what we have here is a reaction force here and a reaction force here, and this is what I'm going to call R little r, and this I'm going to call RQ. And what we can do, because we know that the rod will remain horizontal and in equilibrium, is we can resolve up and down, and we can say that RQ plus RR is going to equal 40 G plus 80 G, and that's going to equal 120 G. So I'll just write this over here. RQ plus RR equals 120 G, and I'm going to call that equation number 1. What we can also do is take moments about Q, and what this does is eliminate this force here, because if we take moments about it, it must be balanced on both sides. And what we have is this force here and this force here are working in the same relative direction. So we can say that 0.4 times 40 G, and that's where Beatrice is sitting, 0.4 meters away from Q, with a force of 40 G, plus 1.6 RR, and that's going to equal 80 G times 0.8, and that's because what we have here is the combined force exerted by Arthur and the centre of mass of the plank, and that is 0.8 meters away from Q. What we get is 0.4 times 40 is 16, and that's going to equal 0.8 times 80 is 64. What we can do is take 16G from both sides to get 1.6 RR equals 48G. Finally, we divide by 1.6, and we get that RR equals 30G, and we can leave it in that terms. Let me just create some more space, and we can, what we can do now is we can call this number 2, and just here we can plug 2 into 1 to get that 30G plus RQ equals 120G. Take 30 plus from both sides, and we get the RQ is 90G. What we now have is what they've asked for, the magnitude of the normal action between the plank at the legs Q, that's 90G, and at R, that's 30G. And just to make sure that on your diagram or a diagram that you draw yourselves, label your forces of the reaction, stating what they are, because otherwise you may not get the marks if you write it like this at the end. Thank you for watching, and join us again for the next part.